Hello, in this video we're going to go through this problem here. So given A is 1, 1, B is 4, 1, and C is 3, 7, we want to find the area of triangle ABC. Now one thing I like to say and remind students when working with problems that deal with triangles is always keep in the back of your mind triangle types. If you have a triangle, always stop and ask yourself, is it a right angle, an isosceles triangle, an equilateral triangle? You know, any of those major types, because often by identifying the type of triangle, you will find shortcuts and tricks to working through a specific question. Now that being said, I don't know if that's the case here, but let's start by drawing a picture. Now I put the grid on my OneNote so I can actually do a scaled diagram here, but again, you don't have to draw a scaled diagram in this case. Sometimes it's useful just to draw in the spirit of the question. So we have an XY grid here. And this is going to be my point A, which is 1, 1. Let me change my eraser type here. So this is going to be A, which is at the point 1, 1. B, which is going to be 4, 1. 1, 2, 3, 4. There's B, which is 4, 1. Then we have C, which is 3. 1, 2, 3, 7. 1, 2, 3, 4, 5, 6, 7. So there's C. And C, which is at 3, 7. So if I connect these now, they don't have to be perfect by any means. There's my triangle. So I want to find the area of this triangle. Now, one thing that, like I said, we want to look to see if this is any special type of triangle. And I can pretty quickly remove that it's right. It's obviously not equilateral. It's not isosceles. So I don't see any quick tricks here in terms of solving this. Now, if we want to find the area, remember, the area for a triangle is equal to 1/2 the base times the height. So the thing is this triangle is not easy to substitute into the formula because finding the height of this triangle isn't particularly simple. If we think of AB as being the base, the height is going to come down from C, like this. So what I could do here is I could say, okay, well, A is going to be, if we look, we can figure out this point here actually. So it's 1, 2. So this is going to be, let's call this the point D, and we're going to put this at the point 3, 1. So I can find the base. So let's do 1 here. Let's find base. So the base is going to be the distance of AB. Now, of course, you can read this right off the graph. However, I'm going to actually do the math just to remind us of the distance formula. So 4 minus 1 squared plus 1 minus 1 squared, which is equal to the square root of 3 squared plus 0 squared, which is equal to the square root of 9, which is 3. Okay? And then 2. We're going to find height. So the height is going to be the length of DC. So that's equal to the square root of, and again, I could read this right off, but let's plug it in our formula. 3 minus 3 squared plus 7 minus 1 squared. And I could work this through and I should be able to get 6. So therefore, the area of triangle ABC is 1/2 the base, which is 3, times 6, which is equal to 9, if I've done my math right. So 9, and let's put units squared. Okay, so that's one way to do this. What's nice about this problem is we have a nice horizontal line for our base, so it's easy to drop that perpendicular and find the height. But let me show you another way to do this problem, which is useful. I'm just going to pause it and copy some stuff and reset up, so just hold it with me for 1 second. Okay, the screen probably jumped there, but you'll notice I've just gone and redrawn the diagram down here. So here's a little trick with these problems. Generally speaking, triangle problems are pretty easy if you can find either a horizontal base or if it's vertical, because it's easy to drop that perpendicular. But in the case that you don't have a nice base like that, what I like to do is I like to think outside the shape, and this is something we want to develop. When we have to find the area of the base or something, the area of a shape. Apologize for the dog barking in the background. What we do here is one thing is we're going to add some lines to this diagram here, and I'm going to extend it out and make a box, just like this. So what you notice now is we have this rectangle, and rectangles are pretty easy to find the area. But what's really nice about this is that I could figure out this point. So let's give this point the point E, and we're going to call this 1, 7. And let's give this point here F, and we're going to give this a value of 4, 7. Well, we can see this is pretty easy. This is a height of 1, 2, 3, 4, 5, 6. And this is a length of from here to here. 1, 2, 3. So we know the area of AB, A, B, F, E is going to be 6 times 3, which is equal to 18. So now, if I can get the area of this shape in here and this shape in here, I can then subtract it from the area of the rectangle, and then I get the area of what's left over. So again, because those two triangles are right triangles, it's really easy. So let's do area of AE, and let's call this point here G, shall we? Oh, sorry, that's point C. What am I doing? So let's do the area of triangle AEC, and that's going to be 1/2. The base is going to be, let's say, 1, 2, 2 times 6, which is going to be 6. And now let's find the area of BFC. And so that's going to be 1/2, 1 times 6. So then we're going to get 3 here. So therefore, what we can say, the area of triangle ABC is equal to 18 minus 6 minus 3, which is equal to 9 units squared. So see how I get the same thing? So like we've said a number of times, there's lots of different ways to approach a problem. Depending on the problem, different approaches are more efficient than other ones. Anyways, I hope this helped.